So far we completed 4 sessions, right? DevOps introduction, question and answers, cloud introduction, and also SDLC, right? Software development lifecycle. So 4 sessions completed. So today and tomorrow we are going to work on servers, networks basics, right? So what is server? Why we require servers? So in real-time projects, always developers develop the code on servers, right? So always we create cloud servers. We hand over to project team when they need it, right? So developers they raise their tickets request as per the requirement. So we receive the tickets, we can work on the tickets, we can create the servers resources whenever they need it, right? Yeah, so this terminology is very, very important. Servers, networks, terminology is very, very important. So if you understand this terminology, we can easily cope up in the cloud environments, right? Yeah. So today's agenda here is what is server, types of servers, server client model, and best practices, server architecture, is operating system, types of operating systems. So up to here you can cover. This will take 1 hour. Up to here we can cover today. This will take 1 hour. So tomorrow we are going to discuss about networking, what is network, types of networks, what is IP address, what is subnet, gateway, router, firewall, failover, load balancer, right? These are all we can discuss tomorrow. So today, tomorrow, these are basics only, right? Very basic. So day after tomorrow, we'll start AWS. From 9th onwards, we'll start AWS. Okay. Yeah. Slowly we'll enter into AWS Cloud platform. So don't directly go and create resources, right? So day after tomorrow, we create AWS account. We can walk through the console, complete console. We can walk through. So what are the options available? We can discuss that. So later, slowly, we'll start working on the AWS resources. Fine. So anyone newly joined today, can you share your WhatsApp number and email address in the chat? So any new guys joined today, can you share your WhatsApp number and email address in the chat? So my mobile number is 96422 is my number. So my name is Ram. I'm DevOps and AWS trainer. You can share your WhatsApp number, email address so that we'll share with you previous recordings. Fine. Yeah. Now let's go and start our basics. Okay, servers. So from day after tomorrow, from 9th onwards, lab sessions will be started, right? Practical sessions. Today and tomorrow, these are all very basics. Okay, theoretically we can discuss. So our course is more into practical only, practical oriented. Okay, so day after tomorrow we'll start AWS. So from day after tomorrow onwards, you need to yeah, prepare your laptop to practice. Okay, everyday daily basis. So if you practice daily basis, you'll get you can easily crack your interview within the 3 months. Fine. Yeah. First one, what is server? What is server? Right? Anyone having idea what is server? Fine. Yeah. Online guys, what is server? Yeah. Server is a computer, right? Server is a computer, right? So server will have high computing power, like high CPU, high memory, high storage drives, right? High capacities, high yeah, data capacity, right? So this is the server, right? So normally servers we can see in data centers, right? What is data center? Anyone? Data center is a server room. Data center is a server room where we hold all the servers, right? So developers always work on the developers always develop the code on server. They don't develop any code on their local system, right? So if they develop any code on local system, if the system is crash, hard drive is crash, memory model is fail, right? What will happen? Data may be lost, right? So server side, so we'll have multiple RAM modules, multiple processors, multiple storage drives also. In case one drive is failed, nothing will be happen from server side. But desktop laptops, only one CPU, one RAM module, one hard drive will be there, one storage drive, right? Yeah. So what is the definition? Let's try to understand. A server is a computer that serves information to other computers called clients. This server serves the information to other computers called clients. Can connect to a server through either a local area network or wide area network such as the internet. Right? Yeah, is this servers we can connect through local area network, which is a LAN or WAN or Wi-Fi. We can connect our servers. Fine. Types of servers. Types of servers. So three types of servers are there. See here. So these are all traditional servers. These are all traditional servers. So if you understand this terminology, you can easily understand cloud terminology, right? Yeah. So first one is blade server. Blade server. It is a thin server. Blade server is a modular server. Module server. So these are very thin server. One container is there. So instead of this container, we have different blades are there, thin servers. Second one is a rack server. What is rack server? This is the traditional server. Most of the data centers, yeah, they are using rack servers. Third one is tower server. It is a bit older server. This is bit older server. Let us go with one by one. See here, blade server. A blade server is a modular server that allows multiple servers to be hosted in a smaller area. So in this smaller area, we can host multiple servers, blade server, thin servers. These servers are physically thin and typically only have CPU, memory, integrated network controllers. Sometimes storage drives inbuilt. So most of the thin servers, blade servers will not have any storage. Without storage, how it will work? Without storage, how the server will work? Anyone? Any guess? Storage is mandatory, right? For every laptop or desktop or server. But without storage also this will work. How it will work? So backend will connect external storages. Backend will connect external storages. So blade servers often seen in large data centers, enterprise level data centers like Google Data Center, UHG, Verizon. This type of companies they are using blade servers. These are very faster, bit costlier also. These servers. Okay. Second one, rack servers. A rack server is a server mounted inside of a rack. Rack servers are typically general purpose servers that support a broad range of applications and computing. These are the traditional servers, rack servers. Most of the data centers they're using the rack servers. Next one is a tower server. A tower server is a computer that is built in an upright cabinet that standalone and that is designed to function as a server. This is bit older server. So in this tower server, one tower will be there. Instead of the tower, one CPU, one keyboard, mouse, one monitor will be connected here. This is bit older server. These are the three types of servers available in the data centers, right? Next one, client server model. So this is server. Through network, we can connect our server by using laptop or desktop. So when we send request to the server, it will give response, right? So normally developers, multiple developers, they start working on the development activity, application development. They always connect the servers. They always store the data in the servers only, right? So when they request, server will give response immediately, right? So yeah, this is a another client server model, right? Yeah. Now, server architecture. This is very very important. What is server architecture? See here. Server architecture is the foundational layout or model of server. So based on which a server is created and are deployed, it define how server is designed. So let's go and discuss about few examples here. Okay. Server architecture. So first phase of implementation. Initial stage of implementation. So we can say first phase of implementation. first phase of implementation. Yeah. So in 1990s, in 1990s and early 2000. So project teams used to design the server architecture, right? How they used to design, let's try to understand. This architecture is very, very important. Yeah, so in 1990s and early 2000, how they designed the server architecture, how they used to implement the activities, let's try to understand. Okay, for example, we have four applications are there, four applications like Java, and C, C++, and Tomcat, and also Python. For example, it's four different tools, four different applications are there. Okay, so in 1990s and early 2000, when they want to build any server architecture, how they used to build, how they used to deploy the applications. Let's try to understand. So this is very, very important. Okay, yeah. So in 1990 and early 2000, when they want to deploy packages, they used to take one server for one application. They used to take one server. We have four applications are there, right? Here they are taking four servers. Okay, so one application, one server. So in 1990s and early 2000, they used to take for one application, one server. So by the time highest capacity of the storage is 1 GB. By the time highest capacity of the storage 1 GB storage. These are all 1 GB servers, right? Yeah. So here, for example, in this server, they deployed Java. So Java will take, for example, 300 MB, for example. Okay. So remaining space will be wasted, right? One application, one server. They used to design. So they deployed Java. Java occupied 300 MB. Remaining space 700 MB will be wasted, right? So 1 GB means 1000 MB, right? Yeah. So 700 MB will be wasted, right? Yeah. Second server, they deployed C++. It's occupied 350 MB, for example. So remaining space will be wasted, right? 650 will be wasted, right? Yeah. So next one, Tomcat. So Tomcat occupied, for example, 400 MB. Remaining space will be wasted here, right? So next server, Python. We deployed Python. So it's occupied 450 MB, for example. So remaining 550 will be wasted. Yeah. So in 1990s and early 2000, they used to take one server for one application, right? So by the time server costing is very higher, by the time server costing, it was very higher, too much cost, right? Yeah. So server utilization is very less, but costing more. Server utilization is very less, costing was very high. So that is why this concept is failed concept. This concept is failed. One application, one server. So that a hardware costing, higher costing. Project used to spend more billing for the hardware, right? So that is why this is the failed concept. This concept is failed. Okay. Yeah. So in second phase of implementation, this is first phase, right? In second phase of implementation, in second phase of implementation, so what they did here, They used to take, project teams used to take, so high-end capacity of the server, one server, they used to take one high capacity server. They used to deploy all the packages in the same server, like Java, C, C++, Tomcat, Python. So they used to take one server, they used to deploy all the applications on single server. So here what will happen? Java user may access Java application. Okay. So the C, C++ user may access respective application. Tomcat user may access Tomcat application. Python user may access Python application. Right. So four users they log into same server, they access the respective applications. Right. Yeah, that is fine. But here the drawbacks are, yeah, this Java user, this Java user may access C++ also. Yeah, this user may access Tomcat also. This user, Tomcat user may access Python application also. There may be chances to access. There may be chances to access. Security will be there. Security will be there. But there may be chances to access. For example, four people are staying in one double bedroom flat, 2 BHK flat. Okay. So two people are staying in one bedroom, two people are staying in other bedroom. Right. So the four people commonly access kitchen and dining, right? Because they are entering to the same flat. There may be chances to access other applications also, right? So Java user may access C, C++. So yeah, this user may access Tomcat, this user may access Python. There may be chances to access because four people are entering into same server. That is one drawback. And also, in case the server is crash, what will happen? All the applications will be gone. This is also failed concept. So second phase of implementation also, second model also, this is failed concept. Okay, yeah. So after 2000, after 2004, virtual servers came into virtual servers. Virtual server architecture. So which is a third phase of implementation. In third phase of implementation, virtual servers came. Virtual servers. Virtual server architecture. What is virtual server? What is virtual server? You know? Can you come in? Okay. So virtual server is nothing but it which is not physical server. Virtual server is not physical server. It is a imaginary server, right? Yeah. In virtual server, we take one high capacity physical server. This is physical server. So this server we can say base OS, base operating system. So on top of this, we deploy one software like VMware, VMware or hypervisor, hypervisor or Citrix. So these are all virtual layers. These are all virtual layers, virtual softwares. So normally in our laptop also we deploy VMware, right? In our laptop also we can deploy VMware. Anyone having idea VMware? Virtual, yeah, virtual software, virtualization software, VMware or a hypervisor or Citrix. So on top of this base server, we can deploy VMware or a hypervisor or Citrix. This will allow you to create virtual servers. This layer will allow you to create virtual servers. Like this, you can create virtual server. These are the 25 virtual servers. On top of this base server, we can create virtual servers. Okay, so different operating environments we can create here. Different operating environments like, yeah. So here Windows 2016 server. So here RHCL, Red Hat Enterprise Linux. So here we can create SUSE Linux. Okay, here we can create CentOS Linux driver. Here we can deploy Windows 2022 also, right? So like this, we can deploy different operating systems on top of the virtual servers, right? So this is the base server. On top of that base server, we can deploy one software which is VMware or hypervisor or Citrix. This will allow you to create the virtual servers. Virtual server is a server which is not physical server. This virtual service will depend on the base server, right? So this base server will have high capacity. This base server will have high computing power like RAM, 48 GB, cpus cpus 32 core, and storage HDD or DDR, HDDR, uh, SSD, 10 TB, like this. Okay, yeah, storage 10 TB, 20 TB, like the server side. So these resources will be used by virtual servers. As per the physical server capacity, we can create the virtual servers. Here we have 25 virtual servers are there, 25 servers. Okay, 5 into 5. So this servers will take the resource from base server. Okay, yeah. So still we are using virtual servers in projects, but here some drawbacks are there. What are those? So if you want to deploy operating system, if you want to deploy Windows 2016 on the virtual server, we require one ISO image. What is ISO image? Anyone having idea?
Windows operating system.
Right, Windows operating system image. For example, in our laptop, if you want to install Windows, we require one image, right? So we copy into pen drive, we connect pen drive. So the pen drive we can configure as a bootable drive. By using pen drive, we can boot and we can install the Windows, right? Same way, server side also there is a ISO image. So ISO image is a full blowing operating system, full package of the image. Okay. So by using this ISO image, we can deploy operating system on servers. Okay. Yeah. So ISO image size would be minimum 6 GB to 18 GB. ISO image size minimum 6 GB to 18 GB. So these servers are 25 servers, right? So on an average, each server can take 10 GB, for example. 10 into 25, 250 GB will be utilized for only operating system. Only operating system we have to spend 250 GB. On top of that, again we have to install Java, Python, right? So packages like DevOps tools. So it will take more space, it will take more storage, right? Yeah. So and also when we restart this server, when we restart or reboot, the servers will take 4 to 8 minutes to restart server. 4 to 8 minutes it will take. Normally, desktop or laptop, when we restart, it will restart within few seconds. But server side, servers we don't restart every day. We don't restart, right? So monthly once, quarterly once. So in our project, yeah, last 5 years, 6 years, we haven't restart Linux servers. Linux servers we haven't restart. Without restart also, Linux servers will work, but Windows servers will not work because monthly patching happening on Windows servers. Once we install patches on Windows server, we have to restart. Okay, but Linux servers no need to restart. Without restart also, they work well. Okay, yeah. So when we restart any server, it takes 4 to 8 minutes. Okay, normally client will not accept for 4 to 8 minutes. Right? This is also one of the drawback. And also deployment time and downtime is higher. Deployment time and a downtime. is high. What is deployment time, anyone? What is deployment? So when you want to deploy any packages, takes more time. What is downtime? Downtime is a maintenance time, right? So normally monthly patching activity, monthly maintenance activities will be happened, right, in real time projects. So deployment time and downtime is higher here, high. So when you want to deploy packages, it will take more time. When you want to down the server, it will take more time to restart or yeah, reboot. These are all drawbacks. Still we are using virtual servers in projects, but these are the drawbacks. Okay, clear, right? Virtualization, third phase of implementation. So here some drawbacks are there. Okay, yeah. So here ISO image, when we use it will occupy 6 GB to 18 GB. For example, each server can take 10 GB, 10 into 25, 250 GB. On top of that, we need to deploy all the packages that will take more space. And the restart time is higher, and downtime deployment time is higher. So that is why, so project teams, these are all drawbacks. These are all drawbacks. Okay, that is why project teams are looking for advanced server architecture, which is fourth phase of implementation, which is very important, which is very advanced one, which is Docker container architecture. So most of the project teams are migrating to Docker containers, Docker container architecture, which is the latest one, which is trendy. Currently, most of the project teams, they are migrating their applications to Docker containers because this is the advanced one, latest one, right? So most of the project teams they are using. So in Docker architecture, what will happen? Let's try to understand. In Docker container architecture, so we can take one server, same as virtual server. Here we can deploy, we can install Docker server, so which can be cloud server. This is we can say AWS server. Okay, so on top of this, what we will do, we can deploy one package which is Docker image. Docker image, yeah. So once we deploy this package, this will allow you to create Docker containers like this. So these are all containers, Docker containers. This we can say Windows 2019 container, for example. This we can say RHL, Red Hat Enterprise Linux. This is Ubuntu. This is Windows 2023 also available. Okay. So this type of yeah, these containers we can create on top of the Docker server. Okay. So once we run the container, so only here lib and bin files will be created. Lib and bin, which is a library binary files only. So when we run the container, only library binary files will be added into the containers. So only library binary files. Okay. So this container size, which is 200 MB only. 200 MB. So here, when we run the container, it will take only 200 MB. So here, when you create virtual server, it takes 6 GB to 18 GB. So this is a lightweight. This is heavy. This is a lightweight. This is heavy. So what is the difference here? So when we have lightweight, it would be very faster, right? So currently we are using online shopping, right? Like digital applications, Flipkart, Amazon shopping site, Myntra, Meesho, Trends. These are the online shopping applications, online digital applications. So even though when you want to book groceries, we book the groceries within 5 minutes. We can within 4 minutes, 5 minutes, we are getting the groceries also. So Jepto, Danjo, Blinkit, these are all digital applications. So why they are processing very faster? Why we are getting that within 5 minutes, 10 minutes? Because of backend there are Docker containers. So if they use servers, that take more time, but they are using Docker containers. Backend they deploy the applications on Docker containers. That is why, yeah, it is so normally when we book any products, so that the request will be processed very faster, right? So recently I booked one mobile. They delivered within 4 hours, within 4 hours. So recently, a few weeks back, I booked one mobile. So they delivered within 4 hours. How they deliver? They have a local warehouse, right? So yeah, they deliver within 4 hours. The process happened, the process, because backend they are using digital applications. Backend they are using Docker containers. So Docker containers are very faster, right? So when we raise a request, that will be processed within few minutes only, right? Yeah. So this containers, yeah, once we run the containers, only library binary files will be created. But so here, this is ISO image, right? ISO image is nothing but full blowing operating system. But this is a Docker operating system is not full blowing operating system. So when you want to deploy any application, only binary library is enough to you. So normally, developers develop the code in their local workspace. Once development is completed, they push the code to remote repositories. From there, we can take and we can deploy onto respective environments. Okay. So if you want to deploy any application, so this library binary files are enough. No need to go with the full blowing operating system. Okay, so both are same functionality, but here only required files only available in the Docker here. So for example, if you create server by using ISO image, so all the graphics will be available, paintbrush will be available, media player will be available, drivers will be available, right? We don't require all these things to deploy the application, right? So here only library binary files will be created. So client requirement is the application, whatever application they developers, that should be deployed onto containers or servers, right? So containers are lightweight, very faster, right? Yeah. So once we run the container, within 1 minute that will be run. It will occupy only 200 MB only, 200 MB of the storage, right? So when you want to restart, yeah, this container will restart within 15 seconds only. Within 15 seconds, we can restart the container. Okay. And also deployment and downtime is very less. Deployment time and downtime is less. Right. So that is why currently most of the project teams they are using Docker containers. There, yeah, and moreover, this Docker licensing cost is very less. Licensing cost is very less. So client always look for the cost saving, right? Client always look for the cost cutting, cost saving. So licensing cost is very less. Docker licensing cost is very less compared with VMware virtualization. Okay, yeah. So this Docker implemented in 2013. 2013. This Docker implemented in 2013. So from 2013, it is evolving. Currently, it is very trendy. So most of the project teams they are migrating applications from virtual servers or physical servers, from virtual servers or physical servers to Docker architecture, Docker containers. So this virtual servers operating system cost is very higher, and also it will occupy more storage. Deployment time, downtime is higher. But whereas Docker containers, So yeah, deployment time and downtime is very less. It will not occupy more space, and also it is very faster. Licensing cost is very less. These are all advantages of Docker. That is why so most of the project teams they are migrating applications from virtualization to Docker containers. Clear, right, everyone? Yeah. So Docker implemented in 2013. Before Docker also, we used to use containers. Before Docker also, we used to use containers, which are like LXC. LXC, one type of container is there. LXC, which is a Linux container. Linux container. Before Docker, I'm talking about before Docker, we used to use some containers. Okay. So LXC is one of the container we used to use. Second one is Jones. Jones. Jones is the Solaris container, right? So next one is LMCIFI. LMCIFI. So full form is let me container for you. This is a Google container. Okay. So before Docker, we used to use these containers, but these containers are failed. These containers are failed because these containers are failed because these are all platform dependent containers. These containers are platform dependent containers. What is platform dependent?
What is dependent?
These are all platform dependent. So LXC will run on only Linux. LXC will run on LXC will run on only Linux. Jones will run on only Solaris. LMCI FI will run on only Google Cloud. Right? That is why these containers are failed. But whereas Docker, Docker is a yeah, Docker is it is a platform independent. It is a platform independent. Okay. Yeah. So platform independent means irrespective of operating system, we can run this Docker on any platform like Windows, Linux, Solaris, even Mac OS also. Mac OS also. So Docker will run on any operating environment. Docker will run on any operating environment. That is why Docker is successfully running without any issues. Most of the project teams they are migrating to Docker infrastructure, Docker containers. They are migrating their applications from local to Docker infrastructure, right? So these are all advantages of Docker. So currently Docker, Kubernetes, these two are very trendy. So if you are good in Docker or Kubernetes, you can easily crack your entry, right? So currently Docker, Kubernetes, these are trendy. Most of the applications we are implementing on Docker containers. Clear, right, everyone? Online guys. Any questions up to here, anyone? Why to restart in Windows Server? Okay. So why we need to restart Windows servers? Any real time guys?
Grant updates, grant updates, patches,
Yeah.
in the configuration.
So Windows servers or Linux servers, why we restart? Because monthly patches will be released by Microsoft and Red Hat Linux servers, Red Hat, Windows servers, Microsoft, right? So the patches should be installed monthly. Once install the patches, make sure the server should be restarted, Windows server. Otherwise, the changes will not be reflected. So even though in our mobile also, we get some updates, right? Monthly updates we get, right? So once we get the updates, once install the updates, automatically mobile will be restarted. Same way, server side also, Microsoft will release the Windows patches. By the time we need to install Windows patches, we need to restart the servers. Clear, right? Any questions up to here, anyone? Yeah. So clear, right? This is very advanced architecture, which is a Docker container architecture. Okay. So most of the project teams they are implementing Docker architecture. So while working on Docker, we'll go deep dive. Docker will take 7 to 8 days. 7 to 8 days. So Docker is very core tool, advanced tool. So Docker, Kubernetes, these two tools are very important. Okay. Yeah. Next one. So this is the server architecture. While working on AWS Cloud, we'll discuss about this. While working on AWS, we'll discuss about this. Okay. So this is very important. So very easier also. Okay. Next one. What is the operating system? What is operating system? Anyone? Operating
The
system.
operating system.
Yeah. Online guys, what is operating system? So here we discussed about OS, right? Base OS, right? Base OS means base operating system. What is operating system? Anyone? Real time guys.
So the operating system is a platform communicating with hardware.
Right. Yes. Fine. So operating system is a interface between user and the computer hardware, right? So, for example, if you want to deploy any application, we require one interface, right? Yeah. So computer hardware always understand the binary language. Binary language. What is binaries?
Zero one.
Zeros and ones, right? 000 001 100 111 like that. So our hardware, laptop or desktop or server hardware, always understand the binary language, zeros and ones. But a human will not understand binary language. So we cannot understand binary language, but hardware will understand binary language only. So that is why we require one translator. We require one translator. For example, so when we go to Tamil Nadu, for example, we don't know Tamil, for example, we don't know Tamil. So in between you and other guy, one translator required. Right? Same way, so computer hardware will understand only binary language, but we cannot understand binary language. That is why we require one translator, which is nothing but operating system, which will translate from hardware language to human readable language and vice versa for effective communication. Right? See here. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication. So this operating system translate binary language to human readable language and vice versa. Right? See here. Between, yeah, see here, hardware and end user. So operating system is the interface, it will translate the hardware language to human readable language. Okay. Next one, types of operating systems. What are the types available? Single user single tasking operating system. Single user single tasking operating system. In this type of operating system, only one user can log into the system, he can perform the only one activity. Okay. For example, which is MS DOS. In MS DOS, only one user can log into the system. He can perform only one task at a time, which is nothing but single user, single tasking operating system. Next one is a single user multitasking operating system. In this type of operating system, so only one user can log into the system. He can perform multiple tasks at a time, which is nothing but Windows. For example, while browsing internet, we can run background audios, right? One user can log into the system, we can perform multiple tasks. So we can log into the system, we can operate some activities. We while working on some activities, we can perform the background audios, which is nothing but single user multitasking operating system. So next one is multi-user multitasking operating system. So in this type of operating system, multiple users can log into the system. they can perform multiple tasks at a time, which is nothing but Linux and Unix. So currently, most of the data centers, most of the project teams, they are using Linux operating system only, because in Linux servers, multiple users can log in, they can perform multiple activities. For example, while deploying the applications, while deploying the code on production servers, developers will log into the servers, testers log into the servers, DevOps engineers also log into the servers. Multiple users can log into the servers, they can perform multiple tasks at a time, which is nothing but multi-user, multitasking operating system. Clear, right, everyone? Yeah. This networking concepts we'll discuss tomorrow. So networking and other concepts will take 1 hour. Okay. So networking, types of networks, LAN, WAN, MAN, and other networks, right? Yeah. And also IP addresses, subnet mask, gateways, routing table, routers, right? And also failovers, firewalls. These are all very important. This terminology is very, very important. So if you understand this terminology, you can easily understand cloud environment. Okay. So before moving to AWS, first you need to understand this basics. These basics are very, very important. Okay. Yeah. Tomorrow we'll discuss about other concepts which are like what is network, types of networks, IP address, subnet mask, gateway, routers. These are all will be covered tomorrow. Okay. Yeah. So any questions so far? Anyone? Anyone having any questions so far? So our WhatsApp group already created, nearly 20, 26, 28 members already added into WhatsApp group. So if you are interested, you can add into WhatsApp group as soon as possible. So because we'll share all the information in the group only. We will share all the recordings, information in the WhatsApp group only. Yeah. So if you are interested, you can add into WhatsApp group as soon as possible. Fine. So if you have any, if you need any other information, you can reach out to me. You can call me. You can WhatsApp me after 10:30. So my mobile number is 96422 11711. So today is our fifth session. Today is our fifth session, right? So still same link is allowing. So maybe tomorrow link will be changed. Meeting link will be changed because yeah, already we completed demos and the basic sessions also we are working, right? Yeah. So day after tomorrow also we have networking concepts. Day after tomorrow we'll start AWS. Okay. Slowly we'll enter into AWS Cloud. So we can create account, AWS account, and we can go through the all the services. We can walk through the console, right? Once console overview completed, we start working on the services, AWS services. Clear, right, everyone? So if you need any more information, you can reach out to me. You can call me, WhatsApp me on this my personal mobile number. So can you provide? So anyone newly joined. So if you provide, it is fine. Yeah. Anyone others. If anyone joined newly, you can provide a WhatsApp number and email address in the chat. Fine. Yeah, so we can wind up here. So tomorrow, yeah, our batch already started. It will not be postponed. Okay. Yeah. So same timings, 8 a.m. IST to 9 a.m. IST. Okay. So yeah. Any other questions, anyone? Any other questions, anyone? If you want to discuss with me, you can WhatsApp me, call me after 10:30 a.m. Fine. Yeah. So we can wind up here. Fine. Yeah. Thank you all. Classroom guys, any questions you have? Anyone?
It's a middle copy you provide.
Yes, I provide you soft copy.
Software.
Yeah, I provide you soft copy of yeah, all the concepts, AWS concepts, DevOps concepts, everything will be provided soft copies. Fine. You can write up here. Fine. Thank you all.